Thank you all. Thank you for having me. I am based out of the United States. I'm very happy to be here in Oslo today to spend the day with you as a part of our Capital Markets Day. What I can tell you is last year we spent a lot of the day talking about what investments we were making in R&D, specifically around the products and technologies that were going to provide the foundation for Napatech's next phase of growth. Today we're going to spend some time filling in the top of the layer, talking about where, how, when, and why those investments are going to be relevant to the company. First and foremost, it's important to look at the major trends that are happening around us, and there are three. Cloud computing, I think we've heard a lot about it. I think this audience is very familiar with what it is. But the most important thing about the major trends of the cloud is the cloud lives somewhere. The cloud is something that's a part of the world that we live in, and all those applications and services that are running in some cloud environment are running on a cloud network architecture, a physical architecture that resides somewhere. But it's very different than the ones that we've had in the past across enterprise IT designs. The second, the Internet of Things. This is just another phase of connected items. So we heard about light bulbs just a minute ago, wristwatches, fitness bands, appliances in our home, packages being delivered in the mail. Virtually everything that you can imagine, and many that you can't, are going to be connected to the grid in some way. And the piece in the middle that's bringing this all together are the 5G networks. Yes, 5G is just the next generation of mobile communications, and it'll cause all of us to go out and get new phones. But again, at the networking layer, what's happening is they're pushing the number of access points further and further out. And that pushing of the access points out provides much higher bandwidth and a better connectivity experience. What these three things combined is a scale of a network evolution that's never happened before in networking and communications. So across the bottom, you see these gigantic numbers about the number of people that are going to be connected, the unimaginable set of applications that they connect with and consume and use, the large number of embedded systems. So everything from the switches, the routers, the firewalls, the radio access points, just an enormous scale, along with the number of sensors and IoT things that creates a massive amount of data. So you put all this together, there really are not good words to describe how big the change is that's required in the network infrastructure to support all of this. Now, as we think about how big this change is, there's actually a great deal we can learn from history by looking back at the points in time when these scale of changes have happened. And the first one I'd go back to, this chart here is by an industry analyst called IDC, and they've named this phenomenon the third platform. And so the first one they focus on is the mainframe terminal era. And the attributes of this point, it was about computing. In your compute experience, you walked into a room, there was a terminal, and that compute system came from one vertically integrated vendor, probably a large multi-billion-dollar company it was their sheet metal, their monitor embedded in it, peripherals like the keyboard, their proprietary operating system inside, and even their application, their spreadsheet that you were using. And that's how you worked. And yes, in high tech, every day and minute, there are constant new protocols, standards bodies, small companies that get formed, some go big, some disappear. The rate of change is very quick, but the sum of those, when you step back up, form big windows, and the mainframe era was one of them. However, almost overnight, and it would be hard to pick out at the point in time if you were living it, but in hindsight, we can look back and say, the client-server model completely blew that up. And what happened in the client-server era is they took that vertically integrated compute environment and made it horizontal. And the act of making it horizontal opened up a whole new industry of hardware. So the server industry, or the PC industry, was formed. Dell, Gateway, IBM, Lenovo, Next, and many others that some came and went. But now there was an opportunity to innovate across that horizontal plane. Inside of those boxes were operating systems, DOS, Windows, Apple OS, and several others that vaporized over time. Peripherals, keyboards, USB, mouse, all kind of crazy things that you can plug in. But most importantly here, the application layer. Things like gaming and desktop publishing just did not exist. And you think about on our phones, the number of apps that we can download today. The opening up of the system created an era of software innovation that was unseen before. And what I'll tell you here today is the exact same thing in this third platform that happened in the vertically integrated compute to horizontal is now happening within networking. In order to support this giant mobile cloud IoT era, the way people build networks has to radically change. And one of the big consequences is not just the network architecture and the design that we'll talk about in a few minutes, but the type of devices they put in the networks are now being horizontalized. No longer do we have giant custom sheet metal from companies like Cisco, where inside it's their proprietary operating system, iOS, their application, only their network interface or line cards plug into their custom chassis. What we now see in this world of open compute, open networking, software-defined networking, is the ability to use standard, low-cost, high-volume servers off the shelf, put in the operating system of your choice, be it Linux or Cumulus or one of these other folks, the NIC of your choice, the right way to connect that thing to the network, and then now it's a standard compute environment where you can add any application. And yes, some of them will include the things that we know about from the previous era, firewalls and load balancers, but it now creates an opportunity for application innovation, much like that second era. So why the history lesson? There are very few event horizons that happen at this scale among the constant rate of change in high tech. But in each one of them, giant companies that had you stood here on a day like today and said, that big company is going to lose its presence, people might have laughed at you during the coffee break. But at the same time, smaller companies who caught these waves and helped enable the innovation became new household names. And this just isn't the biggest one, or it's just not the next one. It truly is the biggest one of our era. So herein lies the opportunity for Napatech. So when you think about these changes, the cloud definitely sparked the revolution. How did this unfold? First and foremost, the chart to the left shows that servers themselves are moving into cloud architectures, be they in cloud operators or your own private or hybrid cloud. Those are all just locations in time, but it's a new architecture. It's a cloud-based architecture. And as those servers move into a cloud-based environment, the workloads are following them. So all the applications and services that we know about and have yet to envision are following it. And at the end of the day, the standard cost per minute, per hour, per watt, whatever dimension you want to choose, is dropping through the floor. So I don't know what came first, the chicken or the egg, but where we've arrived at is that standard, high volume, low cost servers are now widely deployed at huge volumes, and they're the ideal environment or location to run advanced network and security applications that historically required you to buy a custom piece of hardware that cost tens or hundreds of times the cost. Now, these applications, I include this just as a way to connect the dots here. In all of our careers, in the past 5 or 10 years, there were pieces of confidential IP or data that somebody, perhaps even you yourself, would have said, that will never, ever leave the walls of our company, be it IP, patents, whatever it may be. Now, they're all off of your own compute environment. They're in the cloud, supporting each one of these multi-billion-dollar software companies. I joke sometimes thinking most of the M&A deals that I've been a part of in the past 10 years have been conducted through Box. So you think about the security risks of that and the fact that we all use that today as if it were second nature. But now we have this revolution from the cloud hyperscale folks that have said there's a new way to build networks, new architectures, new products, new technologies to build out this infrastructure. The physical network is transforming. So in order to handle all of these servers and distributed and virtualized environments, they need cloud scale performance. And I'll give you some descriptions of these. The cloud scale performance simply means we're moving away from 1 and 10 gigabit Ethernet to 25, 40, 50, and 100. The speed with which, not only the exponential growth in bandwidth, but the speed with which we're moving through these generations is much faster. The cloud scale innovation. This means when you have a physical network, but the world on top of it is evolving at the speed of software, you have to make the hardware evolve at a faster pace. Long gone are the mindsets of buying a piece of hardware, putting it in a network, and putting it on a 7 to 10 year depreciation schedule. that network needs to evolve sometimes to create contrast in days or minutes, let alone years. So that's where the innovation has to come in at the network layer. Cloud scale economics, you can't build networks of these size if every element is a $50, $100, $300,000 piece of communications equipment with 5 nines reliability. Cloud scale economics now are achieved through standard high cost, high volume servers where the design is hundreds or thousands of dollars, and the failure model is throw it out. If it breaks, throw it out and take another one off the shelf. Cloud scale security, in this new world of software-defined everything with trillions of endpoints and massive amounts of data, the network has to be even more secure than it was in the past. And lastly, when you try to get your head around the enormity of these types of networks, you have to have a new way to manage, operate, and provision it, a new level of orchestration. And this is where whole new technologies have come in. So maybe in some of your readings, you'll see things like software-defined networking, network virtualization, server virtualization, network functions virtualization, which is the fancy word for all of the applications residing in software, and an era of open compute, open stack, open everything. So all of those technical terms are really the underpinning of how you build new networks. Now, not only the networks are changing, but the elements that go into those networks is changing as well. And this is a visual of what I captured in my opening slide. In the past, we had these large vertically integrated communication systems with their operating system, their custom line cards and ports. Now, the same applications and services that went into my network for analytics and security and even in some cases switching and routing can be achieved in these standard high volume, either branded or white box communications equipment with open operating systems, standard Intel processors, and network interface cards. In my earlier part of my career, I was a part of companies that built these types of products. And one of the things that we would routinely do as marketing folks is we would boast about how much time and money we spent in building our own proprietary custom ASICs and hardware to make these things perform. And now it's almost funny to look back and believe that we made those claims because now we can achieve the same performance and security with standard off-the-shelf components at a much lower cost for investment and deployment. So these open and standard high-volume platforms, they are excellent for a large number of applications. However, there are some workloads, some applications where they fail. And in those places when they fail, the underpinnings of the vision of the cloud scale architecture collapse. And so SmartNICs are a new class of network interface card. It is a network interface card that you use when a standard server with a standard NIC fail to perform. And those applications are typically when the work you're doing is very high-intense network and security processing. I, in fact, have one. We can use a little show and tell and pass it around if you'd like. But this is a SmartNIC. This little guy here is going to help change the way people build networks. And what a SmartNIC does, it replaces the standard NIC and the standard server, and it makes the server run faster. It makes it more efficient by requiring the server to use less of its computing resources, and it saves money. The TCO, when you place one of these in versus what you have to consume in that server, drops through the floor. So the benefit of a SmartNIC is it returns the valuable and expensive compute resources to the applications and services that needed that server to exist there in the first place. Now, in any new technical arena, when a problem exists and there's a huge opportunity, you'll find companies and thought leaders attack the problem with different technical implementations. And in the past 2 to 3 years, we've seen companies bring SmartNICs to the market in a couple different flavors. The first class of SmartNICs came from the folks that build traditional dumb NICs, and these are the network chipset vendors. And they have something to lose, right? 10+ million standard servers ship every year with a network interface card in it, and they want to make those things adaptable. The problem here is they are based on custom hardware, or just simply based on hardware that only revs itself every 5 to 7 years. So out of the gate, they don't fit the model of software-defined innovation at the speed of software. There are companies that build SmartNICs out of proprietary CPUs. The word proprietary alone disqualifies them because the ecosystem, the environment, the tools, and the number of applications that are written to them are either going to be very narrow or a significant investment to sit inside of that proprietary method. There are other companies, some public companies, that have built smart NICs out of multi-core MIPS. This is just another type of processor that is open and standard. But the problem here is they are general purpose processors, which means they may be able to be programmed and be efficient for that agility and innovation, but at the same time they're thick and bloated and overloaded, not optimized for the tasks around network and security processing. And there are other companies that have built smart NICs out of network processors and other ASICs that, again, suffer the same challenge of being either low volume, never getting to scale in the number of units they manufacture and ship. So what's happened is the industry, in many ways, has backed up to the FPGA and said the absolute best way to do this, among the alternatives, are FPGA-based smart NICs. And FPGAs are, when you see that card, it's just the chip that sits on the card there, and it's a highly programmable piece of silicon that allows you to reprogram the hardware essentially on the fly, not just at the hardware layer, but the software that interfaces with the applications above it. And Napatech pioneered the use of FPGA-based smart NICs. They've been doing it for over 15 years. And now, because of these industry trends, we're seeing more and more applications and use case for FPGA-based smart NICs. And you don't have to take my word for it. If you just look what's happened in the past year, Microsoft Azure, one of the largest hyperscale cloud operators, has gone public and published 10 different use cases of what they use their FPGA-based smart NICs in their network. And it's everything from network offload, security offload, their Bing search engine offload, compression, encryption, deduplication. These are all technologies that suffer at scale in standard network servers without acceleration. Similarly and related, Intel went out and bought Altera, the single largest acquisition in the history of Intel. Altera is one of the top 2 providers of FPGA-based processors. So what we see is a major industry shift to open, standard, software-defined networks that need acceleration in places where advanced workloads make those environments fail, and the preferred technology is FPGAs. So this is exciting for Napatech. This is where this begins to impact us. For 15 years, we've been building FPGA-based NICs, but more importantly, the software that makes them programmable to adapt to any environment and workload. So at the beginning of our story, we talked about these cloud hyperscale data center folks that sparked this revolution. They were the ones that had the initial problem of cloud scale and needed a new way to build networks with new devices that make them. But they're not the only ones that get to benefit from it. Now that it's proven, many of them on their 2nd or 3rd generation of building networks this way, we see IT organizations of all other sizes racing in to say, I may never be as big as them, but I want to take advantage of all of the things that they've enabled by these new architectures. So we see service providers, be they telecommunication operators, cable companies, or many of the new security managed service providers, sometimes managed security service providers, adopting this. So this is where you hear things about network functions virtualization, NFV, redesigning central offices to look like data centers, virtual IMS. There's a whole list of applications where traditional telco operators are throwing out the big hardware and using standard servers. Enterprises, Fortune 5,000 companies of all sizes can benefit from the scale and economics and performance of these software-defined networks. And we'll see on the next slide the list of applications that are driving them. And then, of course, infrastructure and defense, all different branches of government to fulfill their missions. So this is the opportunity for Napatech. We want to be the leading provider of these enterprise cloud networking platforms for every IT organization, not just the hyperscale guys that invented the technologies. And for the people that take that journey with us, they'll get all the same benefits of cloud scale hardware performance with the speed of the software innovation underneath. Now, among those new types of users that can benefit from this, there are a large set of applications. And the great news for Napatech, they include large, high-growth application segments that historically were not as applicable to us. In the green shaded color here, you can see the places where our accelerators, smart NICs by another name, have been successful. And we've dominated market segments that fit the profile of high-end, high-speed packet capture, time stamping. Now, as these enterprises and telcos move to a cloud-scale network architecture that is software-defined with their applications and services running on standard servers that need a smart NIC, these other applications that are high volume and high growth, they were historically deployed on the custom hardware at tens or hundreds of thousands of dollars. Now these organizations are saying, I can deploy them as software, virtual instances, virtual functions on a standard server if I just get myself a smart NIC. What kind of NIC? An FPGA-based NIC. Who builds the best FPGA-based NICs? Napatech. And so the great news here is the major market trends are allowing this whole new set of applications on virtualized servers to fuel our next generation of growth. Now, as a marketing guy, it's very exciting, but I would begin to worry about how do we fulfill this demand with this whole new class of customers that need a smart NIC and a new range of applications that are fueling their demand. The great news here again is there are well-established channels to market that we can begin to take advantage of. IT organizations, service providers, telcos, governments, banks, hospitals, they all buy servers today. They buy NICs to go in their servers, and they buy the applications to run on them. So we have historically sold to network and security original equipment manufacturers, and we will continue to do so. There will always be appliances and hardware that live in high density, high performance, highly secure areas of every enterprise, and they're going to demand those appliances, and we will embed our product therein. However, because there's a shift to consuming these as servers, server OEMs and ODMs now are a potential partner for ours, where we can say, here's a class of server, here's a set of applications that run best on our smart NIC, and we could bundle that together with them. Software companies. So there are a ton of software ISV companies that have an application that then can point to our smart NICs as a place where they can run fastest. There are truly tens of thousands of enterprise VARs globally that we can partner with that will allow us to extend our reach. And then, of course, we have our direct sales force who will always be out there to generate end-user demand. And very soon, I would envision a Napatech web store where you can begin to purchase these things online directly. So when? The time is now. The chart on the left comes from Gartner. This is their hype cycle for networking and communications. And what it's meant to illustrate here is that the underlying technologies that make up these new network architectures are mature. They're not in this early phase, trials, prototypes, research papers. They are actually widely deployed, mature, and available for multiple vendors. As proof, you look at the hyperscale cloud operators that invented these architectures and technology, they're on their second or third generation. So now we see major RFPs from the rest of the folks looking to copy and mimic it. And the potential here is significant. There are somewhere between 12 and 15 million servers that get shipped every year. Addition to that, between 3 and 5 million appliances. Appliances are nothing more than standard servers that are branded and hardened up a little bit in some way with a vendor's application on it. Additionally, there's a whole untapped opportunity of CPU vendors in the future are going to embed FPGAs directly with their device. But if we ignore those just for a second and focus on the 15 to 20 million servers that go out the door every year, if just as small as 10 to 15% of them have a workload or an application that require a smart NIC instead of a standard dumb NIC, we're talking about more than $1 billion in market opportunity. So how are we going to get our fair share of that? First and foremost, we will have a smart NIC platform for the industry, and I'll talk about the products that make up that platform. But a comprehensive smart NIC platform solution is certainly the foundation. But what you can expect to see from us over the next several quarters is a rapid effort to build out a partner ecosystem that shows all of these applications and services run best. So we'll take the best-in-breed applications from established vendors and new upstarts and show them running at performance and scale and price metrics on standard servers that hasn't been seen before. Professional services. This is simply a matter of making it easy to use. Low activation energy, a standard experience where you put a card in a server and it just works. And then finally, a channel program. A slide back, I showed you the list of all those new channels. Those are places where we'll build partnerships and relationships now that it makes sense to. So what does that smart NIC portfolio look like? At the bottom, I talked about the professional services that lower the activation energy to get started with us. On the hardware front, we will have a family of cards. We do today. The key point here between extra small, small, medium, and large is that there will be a smart NIC for every location of your network on a price-performance curve. The one that I showed you today that's working its way around the room is a great example of an extra small version. The bigger ones that you've historically seen from Napatech in the past, they're smart NICs. They just happen to be the extra large versions. And the differences between the ultra low end and the ultra high end are things that the customers require. It might be more memory, more ports, more interface speed, different levels of resiliency. But the point is they're all FPGA based. This is a delivery vehicle, making it easy to use. The value comes in the software and the application engines. And this is where you'll see most of our news in the coming quarters. It's about software packages that are optimized around specific applications and use case, and application engines like Pandion as a 100% line rate capture recording device that allow us to demonstrate specific use cases of an FPGA-based NIC in applications that matter to customers. So to put this all together, we find ourselves today in a new world of networking. It's truly an era driven by cloud, mobile, and IoT that under the hood has created a landscape of software-defined everything. And at Napatech, all we want to do is help IT organizations reimagine their business in the same way that the cloud operators did, by bringing all of those cloud-scale economics to the everyman. This cloud networking platform that includes the items I just showed you, what it ultimately does is it offloads and secures the applications and services on standard virtualized servers. And by being a programmable device based on an FPGA, it provides that innovation level hardware at the speed of software. And again, for the folks that take that journey with us, they'll see all the same cloud scale performance. That card that is working its way, software configurable, can be 10, 25, 50, 40, 100 gigabits, software configurable. You get the stunning economics. These cards now cost hundreds of dollars versus thousands and tens of thousands of dollars, let alone hundreds of thousands of dollars for custom hardware. It's fully programmable, so you get all of the innovation, and it's completely secure. There are many underlying technologies that are probably best served for another day, but at the end of the day, we'll have a family of smart NICs, hardware and software, for every single location of your network that requires it. And this really ties back to last year. It fulfills our vision, our strategy to deliver the right data, to the right place at the right time, every time. So with that, thank you very much, and I'd be glad to take some questions.
All right. Do we have a question or two for Jarrod here? Christer.
Thanks. Just first, you mentioned, you asked a question, who builds the best FPGA NICs, and you answered it, Napatech. Could you be somewhat more objective in terms of comparing your products to the competition, please? I mean, on what basis do you argue that you are best? And in terms of, are there any sort of objective information out there with respect to price performance metrics that we can lean against on that? And secondly, conceptually, NFV has not yet delivered at all with respect to the promises that lie ahead, both in terms of cost efficiencies as well as CPU cycles. So there seems to be a complete redesign of how NFV is going to work going forward. Could you talk about how you see that happening and how your development within SmartNICs is playing into the deployments of the hypervisors out there already? Thanks.
Yep. There's three really good questions in there. The first one was just some of the balanced competitive nature. As I mentioned on this slide, SmartNIC it's not a brand, it's not a trademark that you'll see from us. It's a new product category. It is a NIC. It's a NIC. Why is it different than a standard NIC? It's smart. Well, why is it smart? Because it has something extra on it, the ability to do these offloads and accelerations and software programmability. So then the question is, how do you build a smart NIC? There are a lot of technical options. And as I walk around this slide, I could put names of companies in each one of those hexagons. I think the most important point is that the technical alternatives outside of FPGAs have largely been bypassed by the industry. To a T, they have moved to FPGAs, as evidenced by the two that I reference here on the slide. Now, the question becomes, among the FPGA NIC vendors, where does the expertise come? And the truth is, anyone with enough time and effort and money could build an FPGA-based NIC. What they couldn't do overnight is the software that powers it. And that's what it comes down to. Napatech has nearly 15 years in the software that drives the FPGA, the language that makes it configurable. An FPGA is it's a processor, but it's a type of processor that can be programmed in the field. On top of that FPGA software that changes how the hardware behaves, there's actually an API layer, additional software that you program to. And that combined set of two layers, if you will, on the card with 15 years is something that you just can't make up overnight. And not only have we been doing it for 15 years, we've been doing it for a set of applications that are now high growth, large, and the ones shifting to the cloud scale architectures. So that puts us in the pole position. And that's the opportunity in front of us. We can't make any promises or commitments today, but I can tell you we have a very strong position in this new landscape. As it relates to NFV, yes, NFV was originally defined as a technology standard out of ETSI, European Telco, and there are a large, without, we can't get into specific customer details, but there are a large number of operators, both in North America, Europe, and Asia, who are going through their early stages of NFV trials and deployments. These things, anytime large-scale deployments tend to take time, and I think the industry is working out kinks. So I don't have any reservations about NFV or if. It's more about when and at what scale. The one thing that I do have high confidence in is 5G. Those networks, to get to the scale and the number of endpoints and the way they're being operated and managed, will absolutely be software defined and include NFV. So before any of us have a phone that lights up with a 5G logo on it, we can be sure that NFV will be widely deployed. And with that, I almost forget the third question, so I apologize if I didn't get it.
I think you covered it. Just wanted to follow up, sort of more specifically going back to your positioning. What we see out there is obviously some of your competitors coming out with products that are not only network accelerators but also compute accelerators, so using the FPGA technology to do more. Also with a layer of interfacing it with OpenCL, something that you've chosen not to do as far as I understand. Could you talk about sort of Napatech versus Nalatech specifically with respect to positioning, please?
Yeah, sure. Again, I would anchor it on FPGA-based NIC. The application, because it's programmable, you can target a large number of things. Our historical presence has been in software specific to capture. Throughout this year, you will see additional software enhancements that put us in line, that expands our number of security applications, and the virtualization. Underneath those three simple words of capture, inline, and virtualization, there are a large number of technologies. We've chosen to anchor around the open and standard ones. So technologies like DPDK, OVS, these are things that are not only the way we can deliver the benefit of an FPGA to the market, but they have giant communities associated with them. Our view is anything that's either proprietary or requires the customer to be dependent on the vendor to help them evolve violates the principle of hardware at the speed of software. Also, historically, our applications have been around the network infrastructure. The FPGA allows us to do so much more. The first example was the Pandion recorder line. This allows us to do not only line rate 100% packet capture, but also write it to disk at the same speeds without loss. That's just one example of the power of the FPGA outside of traditional networking. Recently, you would have seen news from us where we did something altogether different around compression with Nokia. We envision a line of further extensions around things that we know large players like Microsoft are doing today, like search offload, deduplication, and more. But more importantly, the ones that none of us have thought of yet. So we can put this powerful, programmable SmartNIC with the basic software for network elements in the hands of people that can do great things with it, above and beyond what we'll ever be able to do.
Great.
Okay.
Thanks, Jarrod.
All right. Thank you very much.